Hello everyone, welcome back to Geeks for Geeks. And in today's video, we'll be discussing our Job-A-Thon 39. This Job-A-Thon was consist of some MCQs and it was containing three different coding problems. And in this video, we'll be discussing about only the three problems that were there. We won't be discussing MCQs. So there were three problems, and now let's discuss those problems. Let's start with our first problem. So the name of the first problem was max distance. And let's read the problem statement. You are given a string S and a character X. Return the maximum distance between any two occurrence of X in the string S. The distance between two occurrence of a character is defined as the total number of distinct characters between them, excluding white spaces and the character X itself. Return -1 if X doesn't exist in the string S or occurs only once. Right? So what we have given a string S and that string contains of some numbers, or it can contain some white spaces like this, right? And we have given a particular number X. Let's say X is A, and in that X there can be multiple occurrence of X in that particular string, and we have to check between two occurrences of X how many different or unique elements are present except our white spaces and X. Right, X itself here, like our X is A, so we won't be considering the occurrences of A. Now here let's see what can we do. As in this example, we can see this BD, BC, DE, FG are occurring between my A, and there I can say this is the white space and this is the white space. So there BC, DE, FG are occurring, and if I exclude these white spaces, I can say 1 2 3 4 5 6. I have six elements in between my two occurrences of X. And besides these two occurrences, what I have to tell, I have to tell the maximum distance, right? Somewhere here, the total number of distinct characters between them, excluding white spaces, return -1 if this doesn't occur. Maximum distance between any two occurrence of X, right? So I'll be considering, if I have multiple occurrence of A, I'll be considering the extreme A's, because between extreme A's the distance will be maximum. So let's understand this with an example. So here we have example. In this we have a string given as Haryana and an X given as A. So in the Haryana string, we have three occurrences of A, one at this index 1 and other at this index 4 and the last at this index 6, right? So we we can form three different pairs, right? We can form three different pairs of our X, but as we have to calculate the maximum distance, as we have to calculate the maximum distance. So we will be considering only the pair with the maximum difference. So we will be considering only this pair, 1 and 6, the leftmost occurrence and the rightmost occurrence. So let's see. In this I have RYAN. In this I have RYAN. And if I look at this, let's also consider these. If 4 and 6 I'll consider, I have only N here. And if I consider this 1 to 4, I have R and Y here. I have R and Y here. So if I look, this is not maximum, this is not maximum, and in this RYAN, you can see this A is the X itself. So we won't be considering this. So the maximum numbers occurring between two occurrences of X is 3. So our answer will be 3 for this, right? So let's see what can we do. How can we solve this question? So in this question, we can have we have three possibilities. Either our number can be any distinct element, or it can be a white space, or it can be X. It can be X, right? Or any distinct element. By this I mean any element, we can say, right? Distinct element is not compulsory, any element. It can be any element, right? So in this case, we will be considering it. We will be considering it, and in this case, we won't be considering, and in this case, and also in this case, we won't be considering it. So in the case if we have any element, there we can have two cases. Either it can be a distinct element or it can be a repeating element, right? In the case of repeating element, we won't be considering our element, but in the case of distinct element, we will be considering our element. So let's see what can we do. So firstly, as for any string, let's say we have a string a b c d a g f a h h a, right? So here we have one, let's say x equals to a, and here we have 1, 2, 3, 4 occurrences of a. So firstly, as we know, we have to calculate the maximum distance. Firstly, we will find the first and last occurrence of a, right? So we can create some variables like first and last, and I'll be putting them equals to -1. And after that, if my first is -1, then I'll update my first because it will be the first occurrence. And after the first occurrence, my first will get updated to some index here, right? Like in this case, it will get updated to 0. And if my first is not -1, then in that case, I'll update my last until my loop ends, right? So I'll iterate this whole string and keep on updating my last. So my last will be standing at this point. And now what can I do to count distinct elements excluding a and white spaces? So I can write some condition like this. If like I'm running a loop, for loop, and if s of I is not equals to a and s of I is not equals to a white space, right? And in that condition, what I'll be doing, as I have to calculate distinct elements. So to calculate distinct elements, I'll be using set. So I'll insert them in a particular set dot insert, and after inserting these elements between the first and last occurrence of my given x, I'll be having all the count of all the distinct elements, and at last I'll be returning the size of my set. So the size of set will be my answer, and the size of set will be containing all the unique elements that are occurring between the first and last occurrence of x, excluding all the particular values of x and our white spaces. So this was the approach. Let's now see the solution. So this is the solution. I have created one first index and one last index, and now I'm running a loop. And if my s of I equals to x, then I have found my x somewhere in the string. And if I have found the x, then I'm checking if my first is updated or not. If it is not updated, then I'm updating my first, else I'm updating my last. And I have created an unordered set, and I'm running from the next occurrence of first index, right? Because I have to consider all the elements in between up to the last occurrence, and I'm incrementing here my I. And if I'm checking if my current element is equals to a white space, right? Here I have checked for white space, and I'm checking if my current element is not equals to x. If my current element is not equals to either a white space or not equals to x, then I'm inserting that in my set. And at the end, I'm returning the size of set, which will be my final answer. So now let's discuss our problem 2. The name of our second problem is coin selection. Let's see what the question says. You have a collection of n coins, each uniquely numbered from 0 to n minus 1. Your friend wants to select exactly k coins from this collection. However, you can only let your friend take the coins if the selected set of coins are valid. A set of coins is considered valid if the sum of the coin values is divisible by a given integer m. Your task is to find the number of valid ways to select k coins. Since this result can be large, return the answer modulo 10 raised to the power 9 plus 7. So in the question, we have given some k coins. Let's take, sorry, we have given some n coins and we have to select some k coins out of these n coins, and these k coins we have to select. These coins needs to be valid, and these coins will be considered valid if their sum is divisible by a given integer m, right? Let's say k is a 4. We have to select 4 coins such that they are divisible by a m equals to 3. They are divisible by 3, right? So we have 7 coins, and these 7 coins are numbered from 0 to n minus 1. So we have coins from 0, 1, 2, 3, 4, 5 up to 6 up to n minus 1. So out of these coins, I have to select different pairs of these 4 coins such that their sum will be divisible by this m, right? This is what question says, and we have to return the answer with 10 raised to the power 9 plus 7 modulo. So let's have a look at example. Here we have example n equals to 5, k equals to 3, and m equals to 3. So we have different coins 0, 1, 2, 3 up to 4, and we have to select 3 different coins such that they are divisible by 3, right? So what are the different pairs we can form of 3 coins? We can form 0, 1, 2, 0, 1, 3, 0, 1, 4, 0, 2, 3, 0, 2, 4, and many more such pairs, right? So for now, let's just focus on how many pairs we can form with their sum divisible by this 3. So this pair will be divisible by this 3, right? Their sum is 3. This pair will be divisible by this 3. And if we take a pair 1, 2, and 3, it will be also divisible by 3. And if it takes another pair 2, 3, and 4, it will be also divisible by 3, right? 3 plus 4 7, 7 plus 2 9, their sum is 9, their sum is 3 to 5, their sum is 6, their sum is also 6, and their sum is 3, right? So we can form these 4 pairs which are divisible by our given m. So our answer will be 4, right? That's what we have to do. We have to find how much different pairs of size k we can form such that they are divisible by this m. So now let's see what we can do in this question. So in this question, as you can see, we have to select k coins, right? So in each coin, we can have two choices. Either we can pick that coin or either we can't pick that coin, right? And if we pick that coin, what the different things that will change? Our k will get reduced, right? As we have to select k coins and we have already selected one coin, so our k will get reduced. And if we pick that coin, our n, the coin we are changing will also change, right? Let's say if we start with n minus 1, if we start with fourth coin, then if we picks it or we do not picks it, it's our choice, and then we'll move to our next coin, and after that we will move to our next coin, and after that next coin, right? That's what we're going to do. And as we are picking coin, what we have to take care of, the main thing is what's the sum, what's their sum, the sum, and mainly not the sum, the remainder we get, the remainder that we get when we divides our sum by this m, right? So we need to take care of the sum of these pair divided by m, the remainder, right? Sum modulo m, the remainder that we get when we divide our sum with this m. So let's see how can we do this question. We have a coin, right? I have taken a coin, and the coin value will lie from 0 to n minus 1, right? That we have already discussed. If we have n coins, the value will lie from 0 to n minus 1. And currently, let's say we are starting from our last coin. We are starting from our n minus 1 coin. So currently, the value of coin is n minus 1. And how many coins we have to collect? As currently we have 0 coins, we have to collect k coins. And what is the value of m? The value of m will remain fixed, like whatever its value will be. And here I have created a rem. This rem is referring to the remainder that I will get when I'll divide the value of my coins by this m, right? Because whenever I'll pick a coin, the m will remain same, but what will change? The remainder that I'll be getting will change. And if after selecting k coins, the remainder that I'm getting becomes equals to 0. After selecting k coins, if my remainder becomes 0, then I can say it is a valid pair. Then only I can say it is a valid pair, right? If I have selected k coins and the remainder is 0, then I can say that it is a valid pair. So let's see what different condition we can have. For each coin, we can have two conditions. Either we can pick it, or, or either we not pick it, right? If we pick a coin, we will move to our next coin, and the number of coins that we have to collect will get reduced by 1, and the remainder will change. How the remainder will change? Our new remainder will be the previous remainder plus the current value of current coin, mod m, right? This will happen. Our previous remainder plus the current value of coin, mod m. This will be our new remainder, and here the current value of coin was n minus 1. So our remainder is changed. As our m will remain fixed, I haven't considered m, right? And if we do not pick a coin, we will still be moving to our next coin, and the number of coins that I have to select won't change as we haven't picked a coin, and the remainder will also remain same as we haven't picked a coin, right? So similarly from here also we will have two choices. Either we will pick the next coin, or either we'll not pick. The value of this next coin is n minus 2. So if we pick this coin, its value, we will move to next coin, which is n minus 3, and the number of coins we have to pick pick now will get reduced by 1. Currently we had to pick k minus 1 coin. Now it will become k minus 2 coins. And now the value of remainder, this was our previous remainder. Now the previous remainder, it will become, let's call it rem. Let's call it prev rem, previous rem. Instead of writing this whole thing, I'm writing it as previous rem plus current coin plus n minus 2 mod m. And if we do not pick our coin, what will happen? We will move to next coin, and the number of coins that we have to select will remain same, and remainder will also remain same, previous remainder, right? The remainder will not change. And here similar conditions will happen here. And at the last, if we keep on going, right, if we keep on going here, I'll be having similar conditions for my n minus 3 coin. Either we can pick it, or either we cannot pick it, not pick, right? So while moving in that condition, what will be our base condition? We can have two base conditions here. So what will be those two base conditions? If somewhere we select our k coins, our k becomes equals to 0, right? The coins I have to select becomes equals to 0. This means I have selected all the k coins. This can be a base condition. And other base condition can be the number of coins I have to select, the number of coins I have to select become greater than the number of coin I have left, and minus, let's say, some x, right? This represents our current coin as well as the number of coin I have left with. So if the coins I have to select and the current number of coins I have ha has a difference, and the coins I have to select is greater than the number of coins I have, this means there's no possible way to select more coins. In that condition, I'll be returning 0. The number of ways to select coins will be 0, right? And if somewhere my k becomes equal to 0, if somewhere my k becomes equal to 0, this means I have reached k coins, and in that I can have two conditions. If I have reached k coins, those two conditions will be either my remainder will be 0 and my remainder not be 0. So if my remainder is 0, if somewhere my remainder is 0 after picking up k coins, this means it is a valid it is a valid set. And if our remainder is not 0, I can say that it is a non-valid set. It is a non-valid set. So in the case of a valid set, I'll return 1 because we have found a valid set. And in the case of not valid set, as we can't move further, we have already collected k coins. So I'll be returning 0. I'll be returning 0, right? So this is what we can do. We have two conditions for each coin. Either we're gonna pick it, either we do not pick it. And as for the base condition, we have when our k becomes greater than my number of coins, right? And minus x. And if my k becomes equals to 0, these are two base conditions that we have. And what will happen if somewhere, let's say here, my base condition hits and I found a valid pair? So it will be returning some value to its function. If let's say it was a valid pair, it will be returning 1. And let's say here I hits here I also hits one base condition and I can't found more coins to select, so I'll be returning 0. In this, it will be adding both of these ways to pick coins, as we have to select total number. If we had to select maximum or minimum, then we will be comparing them, right? But here we do not have to select the maximum or minimum. Here we have to select total, so we will be adding them, and the addition will be returned from this. Similarly, here it will be returning something to this, and at last I'll be getting my answer. So to solve this question, what I'm gonna do, I'm gonna use 3D DP. I'm gonna use 3D DP. I'm gonna create a DP table of three different factors. In this, I'll be having what different things I had, right? My current coin, my current coin, and the coins I have to select, and my remainder, right? The current coin I have, the coins I left, the coins left to select, and my remainder, right? So what does dp of I, of j, of k will represent? It will represent how many different ways how many different ways I can select coin if I have left with n coins and I have collected k coins, and if their current remainder is this RAM, right? So we will be comparing them, and when we hit the base condition, we will be updating them, and we will be initiating our DP with -1, as we do not know how many ways there can be, right? So now let's see the code. So here I have created a memo table. Here I have created a memo table. It is of size n, and it contains another another vector of size k plus 1, which contains which is of size m and contains minus 1, right? As we don't know how many ways we can have, so I have initiated it with minus 1, right? So now I have called this function, I have created the count ways. Let's have a look at this function. Firstly, let's write the size of the dp. It was dp of n of k plus 1 of m. So in this function, I have passed different variables. First is our n, the current coin, k, the number of coins I have to select, reminder, the current reminder, and m, the value with the help of which I'll be finding reminder, and my dp array. So here's our first base condition. If k equals to 0, if I have found the k coins, then I'll be checking if my current reminder is 0. If my current reminder is 0, this means this function will return 1, and otherwise it will return 0. So here we have another base condition. If n plus 1 is lesser than k, so n plus 1 is the number of coins I have left with, and if it is lesser than k, if n plus 1 is lesser than k, this means I can't select any more coins. There's no possible way to select k coins from the remaining coins. In that case, I'll be returning 0. And as I am updating my memo table, as I am updating my DP table, I'll be checking if I have currently visited for the current set. If I have already have some value for that, then I don't need to calculate further. Then I'll be returning that particular value, right? So here comes our main condition, not pick and pick. These are the two ways we can select a coin. If I'm not picking a coin, then I'm decrementing the value of current coin and I'm passing a k, right? As I have not selected the coin, the k will remain same. It has no effect of it, and the remainder will also remain same. M will be always fixed, and the DP table as it is. And if we select the coin, we will move to next coin, right? We will always be moving to next coin, whether we select it or not. And if we select a coin, the number of coins I have left to select will get reduced by 1. Now I have to select k minus 1 coins, and now I'll update my reminder. Reminder will be previous reminder plus current value of coin mod m, right? And here's my fixed m and the table I passed, and I'll be updating the current value of table with the pick plus non-pick, all the methods, all the ways I'll be getting by either picking or not picking that particular coin. It will be the current value of that on that particular index of the table, and I have taken mod, right, to neglect very large values, and I'm returning memo of n of k of frame, right? So I have passed the last variables. As we will be doing, we will be having our base condition on zeros, right? And the DP table will get updated one by one by each step as we have called memoization, and we will be storing with the help of backtracking, we will be storing our final answer in the memo of n of k of rem. This will be storing our final answer. So this was the question 2 for our Job-A-Thon. Now let's look at our problem 3 of this weekly contest. So the name of the problem is Geeks and Game. What does the problem say? Geek was playing a game with his son. Geek's son challenged him to find an array of size n containing non-negative integers that satisfies conditions provided by his son. Each condition consisted of three values, li, ri, and xi. These values indicated that the bitwise end of all numbers within the subarray index li to ri inclusive should be equal to xi. So the geek was playing a game with his son, and His son challenged him to find an array of size n such that each subarray from index li to ri should be having a bitwise end of some xi, right? So we can have multiple li, ri, and xi, and we have to form such an array such that their bitwise end from L index up to R index needs to be some xi, right? That's what we have to check whether it is possible to form such array or not. If it is possible, then we will be returning true. If it is not possible, then we will be returning false. Now, let's see an example. So here we have an example. In the example, we have given n equals to 4, our n is 4, and we have a conditions array given. In the conditions array, first number represents our li, the second number represents our ri, and third number represents our xi, right? This is the start index, this is the end index of subarray, and this is what my and the and of whole subarray, the bitwise and of subarray needs to be, right? This third element represents that. So what does these two conditions mean? If I have an array for, like, these are the indexes, I have an array of size 4, so 0, 1, 2, and 3, it will be having 4 elements, and I want an array such that from index 1 to index 2 they will be having a bitwise and of some 5, and from index 3 to 3, so this element needs to be have a bitwise and of 1. So we have to check whether it is possible to form such array or not. If it is possible, then we will be returning true. If it is not, then we will be returning false. So the 5, we can represent the 5 as 1 and 1, right? 1, 1, and 1, sorry. 1, 0, 1 it will be, 4, 2, 1, and 1 we can represent it as 1. So for the 5, we can write the first element can be anything. Let's take it as something 9, or the second element we are taking it as 5, or third element if we take it as 7, our seventh binary representation will be 1, 1, 1. So we can take 7 here, and at last element we will be taking 1 as the bitwise and of last element needs to be 1, so we will be taking 1. So bitwise and of this 5 and this 7, it has binary representation as 101, and it has 111. So their binary and will be this 1 1 forms 1, this 1 0 will be forming a 0, and this 1 1 will be forming a 1. Their binary end will be 101, which is equal to 5. So yes, it is possible to form such array, and in that case we will be returning true. So what we will be doing, this question, we will be forming an array. We will be forming an array in which from index li to ri we wants to have a bitwise end of some given xi, and if it is possible, then we will be returning true. So firstly, to do that, what we need to do, we need to find whether with the help of which elements I can form such array. Firstly, we will be finding any such elements which can form this type of array, the expected elements which can form such array, and after forming such an array with those expected elements, I'll be checking whether it satisfies the condition for li and ri, li array, li ri subarray, and gives me an result of xi or not. So firstly, let's form this expected array that we are talking about. How we will be forming it? So to form such an array, initially what we have an n, right? Let's take it, let's take its value as 4, and we have a conditions array. It is containing multiple conditions, right? So firstly, what we will be doing, for each L and R, we will be creating an array, and this array will be consisting of some different bits. This array will be of size n plus 1, each number representing the element which can hold that particular index, and this array will be consisting of some 30 bits value. It will be holding 30 bits value, right? And those 30 bits will be representing whether this bit gonna be a 0 or it is gonna be a set bit, right? So let's see what we're gonna use. So the method we are going to use to create such array is the line sweep method. So what is this line sweep method? In this line sweep method, what we do, like we have this array 0 1 2 3 4 5, and we want the sum from 0 to 3 to have some x, and I want from this 3 to 4 have some y. Each element needs to have some x, and here from this to this I want each element needs to have some y, right? If I divide each element as means sum of different numbers, they need to have some x from this index to this index, and from this index to this index I want them to have some y, right? That's how my line sweep works. So for the line sweep method, what I'll be doing, at the first index, at the index L, I'll be pushing my current element. Let's say I push x here, and just after my last index, let's say r plus 1, I'll be subtracting my current element, let's say minus x. And similarly, I'll be doing here at this index 3, I'll be pushing this y, and at this index 4 plus 1, this 5, I'll be subtracting this y. Now I'll add all the other numbers to the remaining numbers. Let's say its size, it starts from somewhere here. This is index 0 and this is index 1, right? So here we initially we will have 0. So now to understand the line sweep, what we will be doing, we have created this x and minus x, and now we will be making each element, each particular index, we will be adding the previous index element to it. So we will start from this index 1, we will add 0 to it, it will remain as it is. Now it has 0 initially, now we will add x to it, now we will add x to it, now we will add x to it, previous element, now we will add previous element to it, x and x will cancel out, we will left with y. Now we will add previous element to it, it will become 0. So yes, by performing this line sweep, I can say this 3 to 4 contains some y, and this 1 to 3 contains some x, right? That's how I'll be doing. That's how my line sweep will be working in this question, and I won't be performing this line sweep in this 1D array. I'll be creating a 2D array, and that 2D array will be looking something like this, right? Let's say if I have created a line array of size n plus 1, and each particular index is containing an array of size 30, which is containing whether my current bit will be a set bit or not, whether it will be a 0 or whether it will be a 1, right? I'll be create I'll be storing that condition. So for each index L to R, what I'll be doing, at index L, I'll be incrementing each set bit such that I want L to R have a subarray and bitwise and of that subarray to be 5. I want bitwise AND of that subarray to be 5. Then what I'll be doing at that index L, let's say I have 1 to 4. So at that index 1, I'll be doing, I'll be for all indexes 0 to 30, I'll be incrementing their particular set bits. So for 5, like 5, I can write it as 101, and I'll be incrementing its set bits, right? It will be storing 101 now, and at index r minus 1, sorry, at index r plus 1, let's say 4, 1, 2, 3, 4, 5. At this index, it will be storing minus 1, 0, minus 1 at the respective indexes. That what we'll be doing. And at the end, I'll be creating some numbers from it. I'll be creating final numbers from it, right? Like it will be containing some binary values if we had some different range starting from this as L, and it will be containing some different binary values if we had some L starting from this range, right? So like it is equal to 5. Let's say it forms my 5, and here let's say at as this is nothing, we will be starting with this 0, and this can be 5. If this does not has any other bit as set bit and it is not changed, then we will be considering the previous array, and it will be remain 5, and here it will also remain 5. And when we will go here, it will add with the previous array, right? So to perform this addition, what we will be doing, we will be using our prefix sum. We will be using our prefix sum. We can discuss that later. Currently, we will be finding our expected array. So to find this expected array, that what we will be doing, we will be creating a dummy array. Let's call it bit, and that bit will be containing the information of previous array, and I'll be adding the information of current array in that too, right? So like initially the bit is containing all zeros, and I go here and I'll add all the information it contains, and I'll go here, I'll add all the information it contains, all the set bits it contains. I'll increase them and similarly increase them here, and here I'll perform the following decrement operations that I have to perform, right? And at the end, with the help of that bit array, I'll be obtaining some integers with the help of those corresponding binary values that I have formed, like 101, 111. I'll be obtaining 5, I'll be obtaining 7, something like this I'll be doing. And the integer, the integer array, the decimal values I have obtained can be our expected array. The integer array that I have obtained can be our expected array. So to check whether it is our required array or not, whether it is our required array or not, we will create a check function, and in that check function we'll be checking the bitwise AND of all the numbers from L to R, of all the ranges from L to R. But when we do that, we can notice one thing. We'll be checking that for each number. So if we run a loop from 0 to n minus 1, and here we have from L to R, right? Let's say we have different L to R ranges. We can have multiple L to R ranges, right? And L to R value can lie from 0 to n minus 1. So their value can go from 2 into 10 raised to the power 5. So if I'll do this, it will makes it time complexity n square. So I need to find some efficient solution with the help of which I can find bitwise AND of a subarray from L to R. So to find the bitwise AND of a subarray from L to R, I'll be making a prefix array. I'll be making a prefix array. How that prefix array will be working? That prefix array will be working in such a way that prefix array will be containing different arrays of similar size 30, and it will be containing all the set bits that I have appeared from like 0 to this index L. And if like I had here, let's create some imaginary array. Let's say I had here 0 1 1 0, and here I had 0 1 0 1, and here I had 0 1 1 1. So the prefix array will look something like this: 0 1 1 0, and here it will look like 0 2 1 1, right? Because this one will be added and this one will be added, and here it will look like 0 3 2 2. And if I have to check whether from this index L to this index R, how many bits are my set bit, so I'll be checking it with the help of as I'm finding AND. So for a particular bit to be a set bit in the while performing AND between some different numbers, each of them number each of those number needs to have a set bit at that particular location, right? If I'll perform the AND operation between these numbers, I'll obtain 0 0 0, because each of this number has a 0 at a position. So to get a set bit, each of the number that is including in my operation, in my expression, needs to have a set bit at that particular location, right? So they need to have set bit, number of set bit equal to the L minus R, sorry, R, as R is greater, R minus L plus 1, right? Here our R will be equal to L plus 3, right? Because let's say it has some value 2, it has some value 3, it has some value 4. So it will be equal to L plus 2, and our final number should be equal to R minus L plus 1, which gives me 4 minus 2 plus 1. It needs to be 3, right? Because if this has a set bit and this has a set bit and this has a set bit, if all of them is having a set bit at a particular position, at a similar position, then their then the sum of that set bit will be 3, which is equal to R minus L plus 1. So I'll check for that. Here I can see only one bit is set bit, so my number will be 0 1, right? 0 0 1 0, which will be 2, right? So if I'll obtain and between these numbers, I'll be getting 2. That's how we'll be doing this. We'll be using prefix sum to find the bitwise and after finding that prefix sum, the bitwise and we will obtain with, we will compare it with our xi, right? The bitwise and I have obtained for my range L to R. I'll be checking whether that particular bitwise and is equal to my sum xi or not. If it is equal, then I'll ignore it and move to the next iteration. If it is not equal, then I know I have to return false because it is not my desired and value that I was expecting. So this was the basic approach. We will be following the line sweep method, and with the line sweep method, we will be following our prefix array method, right? So now let's see the code. We will be explaining the, we will be understanding the code step by step. So here we have our first function. The name of the first function is generate array. In this we will be generating our array, our expected array, generate expected array. So what we have done, we have created an array of size n and a line array of size n plus 1, and it containing 30 arrays. Each index is containing 30 arrays and it is initially containing 0. Each index is containing an array of size 30 initialized with 0, and I'll find my L, R, and Xi. The Xi I have named it as Q, right? So here similarly I'm forming my that array, which will be with the help of which I'll be performing my line sweep. I'll incrementing line of L, I'm incrementing, right? Line of L of bit for each particular bit I'm incrementing it, and line of R plus 1, line of R plus 1 of that particular bit I'm decrementing it. And after that, after creating my line sweep array, I have created a dummy array, and with the help of that dummy array I'll be adding the array I have of size 30 in this, and it will be containing some set bits and some 0 bits, and I'll be adding them to their next arrays, right? So I'm checking for each array 0 to n, and here I'm checking for each bit 0 to 30. If cnt of bit plus equals to, now I'm adding each bit in my current dummy array I have created, and if current bit is greater than 0, if current bit is set bit, then I have created an integer val. Then I am performing left shift in that one and creating my integer val. That val will be the desired decimal value that will be representing the particular element that will represent this binary representation. So after that, I'm storing that val in the array of I that I have created initially. So this array of I will be storing my expected elements that can form my desired array. And after that, after forming that array with the expected elements, I'll be checking whether these elements are suitable or not, whether they performs whether the and bitwise and of L to R range of each subarray is equal to my given Q or not, right? So for that, I have created a prefix array, just like I have told, to reduce the time complexity. And here I am creating my prefix array. Prefix array is of size n, and this is containing each vector of size 30, which will be containing each set bit. And here I am creating my prefix array, and I'm moving to the next and adding these bits to the next, and similarly I'll going to the next and adding these bits to the next, right? Here I will create my prefix array, and here what I'm doing, I'm accessing my conditions array, and I have created L, R, and Q, and here I have created an AND, and with the help of that prefix array, what I'll be doing, I'll traversing through each bit, and I'm checking if L is equals to 0. If L is equals to 0, then what will be the size of subarray from L to R? It will be equal to R plus 1, right? From index 0 to 3, what will be the size of this subarray? The size of this subarray will be 4, right? So for the bitwise end of this subarray to have a bit as set bit, that bit needs to have a value of its size, which will be equals to n, right? N, or I can say R plus 1. So if L equals to 0, if R plus 1 equals to prefix of R of that particular bit, right? The last element of that particular bit is 1, is storing my R plus 1 is equal to my R plus 1. When will it be equal to R plus 1? If all the bits from L to R was set bit for that particular bit, then I'll be obtaining an R plus 1. So if it is, I'll be I'll be making that particular bit in my end as set bit, right? And else if my L is not equals to 0, what I'll be doing, I'm checking for R minus L plus 1, r minus l plus 1, as this represents the size of my current subarray. Let's say L's value is 2 and R's value is 5. It will represent 5 minus 2 plus 1, which is 4. So 2, 3, 4. Right? This will be the size of this subarray. If the number of set bits I have at that particular moment is equal to the size of that subarray. So here I have 0, 1. Here I have set bits up to now, and here I have set bits from 0 to 5. So if I subtract the set bits I have from 0 to 1 from the set bits I have from 0 to 5, I'll obtain the set bits I have after 1 and up to 5. So from 2 to 5. So what I have done, so for the set bits from 0 to 5, I'm calling prefix of r of bit. Here r is representing my last number, and prefix of l minus 1 of bit. L minus 1 is representing just before starting point of that subarray. And if I subtract it, if it is equal to the r minus l plus 1, which is the size of subarray, then that bit will be my set bit. And after all of these operations, my end will be storing the current and the current bitwise and of from the array that I have formed. And if that and is not equals to my q, then I'll be returning 0. If it is not equal, then I'll do nothing. And outside this for loop, after checking each value in my conditions array, I found nothing. I found no value of end which is not equals to 5. Then I'll be returning 1, which is true. And here, this is my main function. I have created my, with the help of this generate array function, I have created my expected array, and then I've passed that expected array in the check function that we have discussed above. And in that expected array, it will be checking whether the bitwise and of all the subarrays with the help of this conditions array that we have passed. It will check the bitwise and of all the subarrays from index L to R, whether they are equal to that particular q or not. If it is not, then our this condition will be returning false, and if it is, then it will be returning true. So accordingly, we have returned true, else we have returned false. So these were the questions of our Job-A-Thon 39. Thank you for watching.